All right, it should be better like this. Please let me know if you can hear me now in the question comment. I'm sorry for that. Can you hear me now? Okay, perfect. Sorry for that. I apologize again. Welcome everyone. My name is Flo. I'm the Corporate Innovation Manager for the US branch of TrueSpares region. I'll be your host today for our tech meeting dedicated to the energy transition. So this session will be recorded, so please let me know if anyone would be against it. So we're going to start, and I'm going to start with the agenda for today. So after a short introduction of what we do, I'll provide some key figures about the overall energy industry real quick. Then we will move to the fireside chat with our experts today. So Julie McLaughlin, Trinity, Lloyd, and Thomas Bladier to discuss the industry and tomorrow's big trend of innovation. We will then finish this event with a selection of innovative companies presenting their solutions and products. So please note that we will answer questions at the end of the fireside chat if you have any to our experts. So feel free to use the question features of Livestorm to ask a question. I can see already that you've been using it. Great. So I'm gonna go on and we can jump into it with a short presentation of TrueSpares region and what we do. So for some of you who don't know us, TrueSpares region is a catalyst for business and innovation. We partner with Fortune 500 corporations in order to support international companies willing to expand and set up business in the Paris region. So thanks to our presence and vibrant tech ecosystem located in San Francisco, New York, Beijing, Shanghai, and of course Paris, we are in touch with over 4,000 international companies every year. So this unique relationship with large corporations on one hand and with innovative, fast-growing companies on the other hand, led us to create the Global Open Innovation Network about 5 years ago. So through this global program, we organize about 20 events a year to foster business and technology partnerships between large corporations and startups. Since the pandemic moved our events online, it allowed us to connect and get in touch with more people, more companies. So I would say it has been a pretty interesting experience. Of course, we cover an area of technologies and topics in our tech meetings. As you can see here, it's mobility, AI, retail. It could be nanotech, energy, like today, and that's the topic for today. So first, I wanted to show you a brief overview of the energy industry. As you can see, you probably know the big actors. It is composed of different companies from various industries. It's ABB, Enel, General Electric, EDF, etc., etc. So here are the key figures I wanted to share today. I wanted to stop on 3 main figures really quickly to set up the base of our discussion with the panel. Today, the global energy market size is valued around $882 billion based on a PwC report. Something important as well is that by 2030, the market is expected to reach $1.977 billion, which is huge, of course. And last, the compound annual growth rate for the materials industry, for the energy industry, is expected to be around 8.4% from 2021 to 2028. So the trends in industries where like new energies are like a prominent trend today, as we can see here, it's of course the solar energy, wind turbines, hydropower, and bioenergy. Great. So to finish this overview of the energy industry, I just wanted to share this non-exhaustive market map with you. We designed it based on different players we have identified on the market. It's missing a few actors, of course, but it gives us a good understanding on what's happening these days. So I don't want to get into too much details. So if you're interested or have any questions, feel free to reach out to me. I'd be glad to either share it with you or tell you how I built it. Great. So without further ado, I'm going to invite our three experts today, for the fireside chat. So Julie, Trinity, and Thomas, I'm going to invite you on stage. All right, so this should come any second. All right, please let me know if you can join me on stage. I believe I've sent the invitation to you. Great. Hi, Trinity.
Hi, can you hear me?
Yes, I can hear you perfectly. Thank you so much. Great. So we're gonna hear for Julie and Thomas. And we're gonna start. All right.
Sounds great.
Perfect. Hi, Julie. How you doing?
Doing well, thank you.
Perfect. Thank you so much. Well, in the meantime, we're going to wait for Thomas, and maybe we can start with the presentation before we start the discussion. Maybe you could present yourself. Tell us a little bit about you, the organization you're representing, and any current project or initiative. So I don't know, Julie, you want to go first?
Sure. Yeah. Thanks so much, Florian. It's a pleasure to be here with everyone. I guess it's evening or late afternoon in Paris. It's morning here in the San Francisco Bay Area. I've been in the energy industry for almost 20 years, mostly in kind of renewable energy. I got my start in the international carbon credit market in the early 2000s, doing kind of carbon credit offset projects. With mostly renewable energy. And then I moved on to kind of energy investment. I've been with large utilities, startups, private equity groups like Brookfield and Carlyle Portfolio Company, and am currently working with Alvarez and Marsal. We are an international professional services firm, about 5,500 professionals worldwide. And the firm got its start in restructurings, probably most well known for having restructured Lehman Brothers coming out of the financial crisis. And from that restructuring heritage, we've expanded to a number of sectors, and energy is a pretty significant sector for the firm. Have about 450 professionals in energy. And I came on board to help develop the energy transition strategy. So kind of previously siloed industries like pure play renewables, oil and gas and utilities didn't have much overlap previously. And now there's kind of, with this transition, there's a pretty significant convergence happening. And just in the last month, we've had conversations with over 40 oil and gas groups about clean energy and their interest in, clean energy and the energy transition. And I just don't think that would have happened, even 3 or 4 years ago. So it's pretty exciting time, I think, to be in the market. And, having been in the industry for almost 2 decades, I feel like this is our moment for the, clean energy people. It's pretty great. So that's me. Looking forward to having this conversation.
Yeah, definitely. Thank you so much for accepting my invitation, Julie. Great, Trinity. Yeah, you wanna go next?
Sure. So Trinity Lloyd. I am the energy transition and sustainability lead for Google Cloud. So I work on taking the vast assets across Alphabet around energy and sustainability, digital assets, expertise, platforms, And sustainability is such a broad term, so it's a lot of different things. And figuring out how to work cross-brand, cross-portfolio for Alphabet through cloud to bring some of those assets and solutions to help organizations accelerate their sustainability goal achievement or innovation in their spaces. And with a big focus on energy and energy transition, naturally, because where energy goes, the world follows. And from a sustainability and environmental perspective, it's obviously a very key component. My background is in technology. Prior to coming to Google, I was working in VMware, running the cloud management teams for the Eastern US and Canada, and have a long history at various large enterprise technology organizations like Dell and Cisco, prior to VMware and Google. What I work on is a whole lot of different things, just based on kind of how I described my role. But currently, my biggest focus area is in how we connect some of these disparate value chains to harness understanding around impactful changes and interventions faster, expanding adoption, increasing adoption of relevant technologies through being able to really understand and show their efficacy.
Great, thank you so much. Very interesting. Thank you for being with us today as well. And Thomas, yeah, you wanna present yourself and tell us a little bit about your organization?
Yes, sure. Thank you very much. I'm so happy to be here with you. So EDF is one of the major European-based utility company. We also present in the US. We are one of the most important renewable energy developer, and as excited as Julie said to be in that market these days. I belong to the corporate side of EDF. I have been managing our research and development team in California. Unfortunately, I have left the country and I'm now back in Canada, but working on a new entrepreneurship project on carbon offsetting.
Perfect. Thank you so much as well. Great. So let's jump into it right away. So usually, like, my first question is a really general question. So when we talk about AI, I usually ask what is an AI company, and I do that for every topics usually. And so to prepare this panel, I actually had calls with the different experts, of course. And so my first question will be for Trinity, because you told me something that makes a lot of sense, and that is like quite forgotten a lot of times. You said that any company consuming energy is an energy company. So can you elaborate on this and why it's important to understand that?
Sure. I think if you just look at Google as an example, certainly Google is not an energy company, but in our own quest for achieving lower carbon impact and footprint in the world, we had to learn quite a bit about our energy consumption and create a lot of innovation around how to optimize that consumption, how to source renewable energy, how to change policy so that we could source renewable energy. And that was a journey, a big, long journey. I think the opportunity that we see is when our systems in place don't necessarily meet the demands of large business, which we see expanding incredibly rapidly right now in terms of achieving these types of goals. Then each organization really has to take it upon themselves to understand their energy consumption and plan their energy use for the future from a renewable energy and lower carbon perspective. And so what understandings we have to have about our own operations from an energy perspective are quite like what an energy company would need to do in a variety of different energy companies. And as the electrification only increases, that only increases more and more rapidly. So understanding the intensity of our energy consumption, how we procure energy, how we diverse and create resilience, all of those things are critical to any large organization today. Just like every company is also a technology company. May not be your core competency, but you have to innovate and create technology to support the growing needs of the business and the markets. And so I see both of those things kind of happening simultaneously. Everybody has to become an energy company, and everybody has to become a technology company.
Yeah, very true. Julie, you wanna add something? Thomas?
Well, I think Google has done a very good job becoming an energy company, both by the services you provide to energy companies, and also the way you are paving the way towards real clean electricity with your 24/7 target. It's very impressive, and I think it's very good for maybe the more energy company of the energy company to have partners like you helping paving that.
Yeah,
Thank
definitely.
you. I agree. I think we all need more partners, cross-industry partners, so that we can actually accelerate some of these solutions, because it does take that sort of collaboration. But thank you.
Yeah, definitely. Thank you so much. So I wanted to come back actually on something that is on the news today. Actually, a few hours ago, the IEA, so the International Energy Agency, stated that the global transition to clean energy is still far too slow to meet climate pledges and risks, fueling even greater price volatility. And that the world is not investing enough to meet for future energy needs. I just wanted to have your comment on this, because it's the news from today. Obviously, it's the we could say that the days before, but what's your comment on that? Maybe Julie, yeah.
Sure. Yeah, I'd love to comment on that. I mean, having come from private equity, whose kind of goal is to invest in assets, and the groups that I've been involved in, that's particularly energy assets and energy infrastructure. I think that oftentimes when we talk about the energy transition and investment, it can be confusing, because the money is there and the appetite is there. They're kind of have shown 2020 was the first year that there was more money invested in renewables than oil and gas. And, kind of Goldman Sachs is projecting that another 16 trillion is going to get invested in the clean energy sector between now and 2020. So there's some really big numbers, and much, kind of that money is flowing into the sector at an increasing rate. But I think what's really challenging is that infrastructure, we have a lot of legacy infrastructure that's not straightforward to replace. I mean, these are mega projects that have implications to communities and to, the environment and permitting, as well as the physics of how energy flows and where it flows. And so I think that the investment's there, but there's also really a need and an impetus for different regulatory bodies, states, countries to work together to overcome some of these really kind of intrinsic barriers to transforming the infrastructure that we need in order to kind of deliver reliable, clean energy, and to ensure that people don't, don't suffer in the process. Being, kind of a native of the Bay Area, and having spent the last, kind of 5 years in this area with the blackouts from the wildfires, I mean, that has huge social implications when you don't have reliability. So I think the problem is extremely complex, and I personally I feel like the financial community is there. I think that there's more kind of needed on the political leadership and the regulatory leadership at all levels, and I would say that's probably true of most countries, although there are a few exceptions.
Yeah, I would totally agree with you, Julie. We had very interesting conversation with EPRI, which is the consortia of US utilities. And the first thing maybe we can remember is that the US have been reducing their greenhouse gas emission. I mean, on the last 15 years, the country have been from 6 to 5 gigaton of CO2 equivalent emissions. So that's a 15% reduction, which is a first good step. But of course, more needs to be achieved. And like you said, Julie, it's not only a financial problem, even if the amount of investment needed are very important, but it's also an infrastructure problem. And infrastructure cannot be solved only by money. You need to bring also the technology. And you also have some very basic supply chain or workforce challenges. If you want to upgrade, for example, the US grid, both on the transmission side and on the distribution side, you would need to have a lot of civil engineering work. And US utility company are working on how is this humanly possible to have all these works, all these equipment changed, even in a decade. It's also a delivery challenge. And you of course mentioned, and I totally agree with you, the regulatory constraints and the permitting issues. This we can see it both in Europe and in the US. It's more and more challenging to build a new transmission line. And guess what? You need them. If you want to have more floating offshore wind on the sea, both in Europe or in the US, you need to bring the power back in the country. You need to have those transmission to connect the various grids and to provide more resiliency. But we all know the NIMBY effect, and that's the more and more important challenge.
Yeah, yeah, it definitely makes sense. So since we're talking about like reducing some the carbon emissions, for example, or investing in renewables, my question is it enough? Of course, you're gonna tell me it's never enough. But like all the reports lately, and that's why I gave the news today, is that we can see that the results and the objectives, even short-term objectives, are not reached. So more than the question, is it enough? We could ask, like, where's the problem if we cannot reach those objectives? Trinity, maybe you wanna have a word on that?
Sure, I have some thoughts. I mean, I think that when we talk about the infrastructure, there's a paradigm shift that has to happen in how we work, not just in terms of policy or even investment, but in terms of how we work together and how we collaborate together. I think that that technology organizations like Google, and I'm very proud of the work that Google does, is they set a lot of pioneering advancements forward. But the role of technology in making those connections and creating that paradigm shift so that we can connect data, we can connect operational strategies, we can connect supply chains, is absolutely critical. And while I think Google has done quite a bit, I think we still have a long way to go. And that goes for all big tech organizations, because understanding how to integrate some processes, building tools that support the integration of these process changes is critical to activating all of the investment funds and assets that exist. It's critical in advancing policy change faster. And it's critical in creating that collaboration so that we know exactly what needs to be done and when. I think the opportunity for large corporations in general is particularly high to push and drive all of that forward. Regulation and policy change is also critical, but if CEOs are intently focused on accomplishing their own energy and decarbonization goals with on-site energy development, we also solve a lot of these problems a lot faster.
Yep, makes sense. Yep, Thomas.
Yeah, what I would add is we have now technology for the next decade. Together with wind, solar, transportation, electrification, energy efficiency, we can achieve maybe 50-60% decarbonization of the electricity grid. And if we do that, we can electrify more and more industries. and we can reach a fair level of decarbonization of the economy. If we want to go beyond that, if we want to go towards 80, 90% decarbonization, not only of the electricity grid, but of all the economy, we need new technology. We need hydrogen, we need carbon capture and usage, we need ammonia to decarbonize, those heavy industry like cement, steel, concrete, which are very difficult to decarbonize. And what is very exciting is that these days we see various streams of innovation, that are dedicated at improving the performance and the delivery of existing solutions. We see innovation around providing more energy efficiency and more carbon footprint mitigation for companies. And we see also more and more hardcore energy technology innovation dedicated to build those new technologies that we will need a decade from now.
Yeah, makes sense. Julie, like for you, what are the next objectives, like globally, that we should take, like I would say, in the next like 10 to 15 years for you?
Yeah, I mean, I think everything that Trinity and Thomas said is makes a lot of sense, and I would fully agree. I would just add that I feel like the consumer and the individual has a big role to play, and I don't I wish I had all the answers, but I don't have kind of all the answers as to how best to engage people. But I think that we used to have a saying in the energy industry, like the cheapest kilowatt is the one that never gets used. And I think you could apply that to carbon as well, right? The most climate friendly, kilowatt is the one that's never used, because kind of all energy has a carbon footprint to some extent, has a kind of constraints on materials and energy intensity. Even those clean energy kind of have some sort of carbon footprint. And so I think finding ways to be more efficient, to change, kind of change patterns. I mean, one of the interesting, shifts that happened in the US during the pandemic is, and I can't remember exact numbers, I think it was like 15%, something in that magnitude, a drop in, carbon intensity from like March to April 2020, when everybody stopped traveling, kind of weekly for work, stopped commuting into the office. And so, I mean, I think that is one of those very positive outcomes of the pandemic, is the realization that there are a lot of jobs that you can do remotely, and that you don't need to be necessarily on a plane every week. Sometimes it is essential to meet in person, but it may not be essential every time. And so I think starting to look at those micro choices that we all make on a daily basis, from kind of a climate perspective, is really critical to kind of making that paradigm shift as a society. So I think everyone has a role to play.
Yeah, very true. So maybe Trinity, kind of the question about what do you see any industries that are kind of late in this energy transition, or if I can rephrase it, like some industry that we still need to work on and to invest in some like renewables and change the way they see this kind of use of energy?
I think there's lots of industries and just even specific organizations that are maybe a little bit late, but we welcome everybody as soon as they get here. But I do think that from an investment perspective, if you're Google and you have large data centers that consume large amounts of electricity, it's a different challenge than if you are a retailer, consumer packaged goods organization trying to achieve the same sorts of goals. And creating energy and decarbonization solutions that are not simply focused on the energy industry, that are focused on all industries and how each individual organization, regardless of where they are on this particular journey, can participate. showing up and bringing your core competencies in whatever industry you're in to develop innovations for your space. Again, going back to every company is an energy company and every company is a technology company. Those are, if anything is late to the game, it's the understanding that we all have to innovate together, no matter what industry we're in. We can't rely on any particular silver bullet to solve these things. It has to be everyone together simultaneously and rapidly.
Yeah, definitely, definitely. So, talking about those innovation, you talk about like the electricity, of course, because Google is using a lot for those data storage. And Thomas, you mentioned the electrification, right? As because it's stated as one of the easiest way or powerful way to decarbonize. And so, of course, we talk about transportation, mobility as an example. Can you explain a little bit more what we could do in those areas to do that, Thomas?
Yes, sure. So regarding electrification of transportation, I think that now the momentum is here. There are a various range of solutions being studied and launched, from electricity to hydrogen. And there would be an interesting, covering of ground transportation with this solution. So the question is how light and small can you make a battery so that maybe you can electrify a truck, or will you have to use hydrogen to move it? And how cheap can you make a fuel cell in order to use hydrogen for even a small vehicle? So this is for ground transportation. Now we have also air transportation, and that is a bigger challenge. So if you want to go from San Francisco to LA, well, maybe one day, not so far, you will be able to do that with either an electric plane or a flying taxi. I don't know how you call it. But if
or
you
maybe
want
a Hyperloop, that would also be cool. I've been kind of waiting for that.
Yeah, let's make that trip. But if you want to go to New York or to Paris, well, it's very unlikely because you will have to have so many batteries that will be so heavy that you will have to have even more battery to carry those batteries. So it's very unlikely that we'll be able to do that with electricity. What we're working on is electric fuels or synthetic fuel. So you could use clean power from clean energy sources to make synthetic fuel, like with a chemical, and this clean fuel you could use them in a plane.
Okay, great. So maybe Trinity, do you see any any other like innovation other than, of course, transportation?
I think there's innovations that have to come from everywhere. I think some of the big innovations that need to occur is really in connecting different organizations and information and data silos. That to me is the biggest and first innovation needed. Understanding carbon emissions, energy consumption from proprietary data, public data, and integrating all those components together, so we can prioritize our interventions with information. I think connecting public and private organizations from that perspective is the critical next step. And we're right there. We're really close. We have the capabilities of doing it. We just have to sort of modify the way we really have to modify our processes and how we think about sharing and collaborating. We've built our infrastructure of business and operations in silos, and that's what has to shift. And creating an innovative tool to do that, harness all the things that are available, because there has been a ton of progress, there has been a ton of investment, there has been a ton of innovation, but it's very disparate, and we need to bring it together. That's, to me, is the next big innovation that's needed.
Yeah, of course. And on that point specifically, so Julie, first, like, what do you think about the this collaboration that Trinity was talking about between different entities or actors, companies, policymakers, even banks, like you said, like earlier, insurances, today to have like a common effort for this energy transition, and what should be done more efficiently, maybe.
Yeah, no, I think again, everyone has a role to play, and the more kind of the more groups, especially financiers, I think do and have been playing a very active role in in kind of deciding which projects go forward and making sustainability a priority. I think CITI Bank a couple of weeks ago kind of announced that they're now only lending to groups that have a comprehensive sustainability program. So those, I mean, those do, money matters, right? And so that those do have an impact. I think one other area, just kind of not to beat a dead horse, but on the kind of existing infrastructure, existing kind of let's say relationships with utilities. I think there is still some innovation to be had there. And while there's a lot of companies, I think Google is certainly a great example that can, kind of ring fence their operations and make them incredibly sustainable and renewable, because they have that intensity and that load to be able to, to kind of support a, kind of 24-hour power between renewable wind, solar, and storage, or what have you. A lot of the users of electricity don't have that capacity, either because of the way their business operates or because of the size of their load is just not sufficient to warrant that shift. So I think utilities need to kind of modernize. Some of them are modernizing. Even I would argue that even the ones that are modernizing could do more, but then there's a lot that have been resisting change and kind of are hunkered in that old vertically integrated business model, and are going to need to be extremely dynamic. To Trinity's point, technology has a huge role to play, because as load shifts and you're if you're charging, let's say, I know some technologies are looking at kind of utilizing your car battery to provide power for your house. And once flows start going in both directions and are unpredictable, then that makes serving them as a utility more difficult and requires significantly more technology investment, but then also technology kind of know-how and integration into existing systems.
Yeah, definitely. Thomas, on a different level, for the same kind of question, in terms of structures, globally, do you think we prepared for like transitioning? Does our electric market adapted to renewables energies, for example, today?
Well, yeah, integrating a high percentage of renewable in the grid is something very important, both on the investment side, but you're right on the market, the way the market where electricity markets are quite complex, but they were designed for assets, for dispatchable assets, meaning a gas plant, a coal plant, an hydro dam. You can decide to launch them, to stop them. You cannot decide when the wind blows and when the sun is there or not. So that causes a challenge to electricity market, and we need to make them more compliant with that. So using your car battery to mitigate, the fluctuation of the power coming from PV system or from wind is a good idea. We need, of course, more storage, but we need also maybe new incentive for investors and for players on this market to have a new way of funding generation. I don't want to be too technical, but the classic generation assets, they are light on the capex and heavy on the opex. if you build a gas plant, okay, it's a limited investment, and the heavy cost is when you burn the gas to produce electricity. While with a wind farm or PV farm, it's the opposite. It costs a lot when you build it, and then it works for free. And we would need to think of new signals on the wholesale electricity market to make sure that our system will actually become greener while staying also as resilient as effective as it is today. And I would like to move back to something that you mentioned, Julie, about having the consumer engaged, having the consumer involved, and changing the way we connect data, Trinity. And last year in California, as you might remember, we had the first blackout that was not for wildfire reason, but because we were missing electricity. And there was many reasons for that. But one thing we might have to remember is we had the distribution generation asset that could have prevented that because CNI customer or even consumer have some storage, some local generation, and it was not activated because there was a lack of connectivity between the utilities IT system and these distributed generation assets. So it's something we have to work on if we want our system to be more effective and more resilient.
Yeah, Trinity, you wanna have a word on that?
Oh, I was just, yeah, I couldn't agree more. I'm in Texas, and we had our own challenges from cold. I was without water and electricity for over a week, and my ceilings collapsed. So I know all too well that reliable energy for consumers is critical. And if any utility power generator at this point doesn't understand that they are in a state of disruption and that they need to innovate, I'm not sure what else needs to, what other proof we need at this point. So I hope that the laggards are starting to at least wake up and say, hey, my world is changing, and I need to get in front of that, because whether they believe in it or not, from a climate perspective, doesn't really matter. We don't have resilience in our structure. We can't support the demands that exist today, and there are phenomenal economical implications to that challenge. So from a purely economic perspective or business perspective, it is solve or be eradicated, right? It will get solved for you if you don't. That's what disruption is. And I think energy is certainly in a state of disruption, but really all industry is in a state of disruption right now. And it's good disruption, it's needed disruption, but that does mean that if you want to stay in whatever you have traditionally done, somebody else will come in and take your place in the new world, right? So hopefully, not to be all doomsday and negative, but hopefully that people are recognizing that it's needed, and it's an opportunity. It's an opportunity because new markets are emerging, new revenue streams are emerging, new opportunities are emerging. You just have to be nimble enough and comfortable enough with the change and committed to that, so that you can capture it. So it's an opportunity.
Yeah, it is. Definitely is. And so, talking about those new markets that are emerging lately. So, I want to ask you, like, if you saw like one technology or like one area that is like either booming or like very exciting for the future. Julie, when?
You're gonna put me on the spot.
No, you don't have to like give me a startup or anything, but
no, I mean, I think hydrogen is one of those areas that is incredibly attractive and interesting. I think the challenge now is a bit of like a chicken and the egg, right? Because there's the pricing isn't quite there because there hasn't been infrastructure investments. But if you don't make the infrastructure investments, then the pricing won't get there. But I think one of the things that's so exciting about hydrogen is that you can you don't have to completely reinvent the way that we operate to make use of that clean fuel, right? In theory, you could utilize it wherever we're utilizing natural gas with some modifications. And it also gives you access to, I think one thing that maybe hasn't been mentioned, but is, I think often forgotten and has a huge carbon footprint is shipping, right? Shipping is incredibly carbon intensive. And especially because of the kind of manufacturing hubs that we've set up in Asia with the consumption hubs in kind of Europe and in the US, and hydrogen is does provide a way to one possibility for decarbonizing shipping. So I think that to me is an area that is very exciting, but and groups like EDF have been making big investments there, but more investment needs to happen in order to reach the scale like we've seen. I think in the last 10 years, if I'm not mistaken, solar costs have come down about 80% and wind about 40%. And we need the same thing to happen with hydrogen to reach scale.
Interesting. So hydrogen on one hand, Thomas, do you see anything else?
Well, my bet was also hydrogen because as mentioned, Julie, one thing we need to know is we shouldn't be where we are now. I mean, PV and wind, their cost curve have declined more quickly than anybody would have bet. And this is a result of, like Trinity mentioned, all the industry, both the consumer, the technology providers, the utilities, working on that. And the key question, or what everybody wants, is to see the same thing with hydrogen technologies, electrolyzers, and fuel cells. We are at the beginning of an innovation cycle on this technology, and if we achieve on these technologies the same decline in the cost curve than we've seen in PV and wind, it could be a real game changer. And the same thing could apply also to, which is not exactly an energy technology, but still can be a very interesting game changer when it comes to climate change. It's carbon removal, and we have some technologies which are challenging, economically challenging, also some acceptability or side effect challenges. If we manage to work on them enough to solve these challenges, that could be huge.
Great. Perfect. Thank you so much. And Trinity.
Oh, I think I definitely agree with Thomas and Julie. I, of course, naturally coming from the Google lens, I also think that unintended reporting and or opening up of proprietary data sets around energy consumption is becoming more and more interesting to a lot of organizations, and is really needed information and data to solve some of these things. So I think that, but from a trend perspective, hydrogen, any sort of biofuels innovation and understanding the viability of biofuels, and also, right, I think just generally speaking, not looking for a single silver bullet, because there isn't one. It's going to be lots and lots of different things that have to come together. And whether in terms of trends, I see more and more organizations recognizing that I don't just need to do this one thing, and I don't need to just invest in this one thing, or even waiting for what is the next thing, right? What is the thing that I should be investing in, and beginning to recognize that it's going to be multiple things.
Yeah, it's not a silver bullet; it's a silver bucket.
Yeah, exactly.
Great. Thank you so much. Very, very interesting. I wish we had the hours to talk about it, but time flies. So we have to move on with the event. I'm just gonna take one question to finish this past panel discussion. So this is a question from Mohammed, and the question is, how do we transition to cleaner sources of energy when we are not monitoring as businesses, regardless of sector, how we use energy. So we can think through centralized plan, but if we can be more responsible users of energy and enable distributed power, can we not reach those climate goals faster? Yeah, who wants to have a word on this?
Well, of course, measuring energy is the first step to begin manage it and reduce it. I think that the distribution, the very distributed organization of energy is one thing. Sharing some assets in common, like the centralized system allows to do, is also a way to lower the need of capex and to bring more resiliency and flexibility.
Yep, that works. Great. Well, thank you so much, Julie, Trinity, Thomas, for your insight. And thank you again for accepting my my invitation today. And
Thank you.
please
It's been
stay.
fun.
Thank you so much.
Yeah,
And
thank you for having us.
yeah, definitely. And so please stay with us for the second part of our presentation today with the presentation of startups. Thank you. Bye bye.
Absolutely.
Sure.
Thank you.
Bye.
Great. So we're going to continue with the startup presentation. So I'm going to invite Sergio for the first presentation, which is Dynami battery. So Sergio, if you're ready. Hi, Sergio. How you doing?
Hi, good morning, good afternoon. Um, it's a hard work for me to come here. I've been listening to this, the fireside chat from these policymakers. So I'm really challenged on introducing on starting the conversation with this with my colleagues entrepreneurs who are as we are making the technology that makes all this happen. It's not magic. It's ourselves that might make it happen, and it's very, very, very hard.
Yeah.
So yeah, I don't want to enter into a fight about hydrogen, but it is not a fuel. Hydrogen is a storage technology and a very inefficient one. But let's go with what we do, which is batteries, which is a very efficient way to
Yes,
store
please.
renewable
Perfect.
energy.
So the floor is yours. You can share your screen and show a presentation.
Can I? Let's see if it works. Yeah. Okay, window. This is the first time on this. Okay, it seems it'll work. Oh no, you're seeing the wrong window. No, sorry.
No, it's perfect. We could see your presentation.
Oh yeah, I couldn't. Wait a
Yeah.
second.
Mm-hmm.
Oh, now I see it.
Yes, perfect.
Okay, and how do I do? Okay, wait a sec. So now you see full screen?
Not yet.
Yes?
Yes.
Okay, perfect. Hi, my name is Sergio and I'm co-founder of Dinami. And at Dinami, we make a technology to give lithium batteries 40 to 80% faster charging. We achieve this by the creation of our Honeycomb Electrode that creates lithium-ion superhighways. And we will use the electric vehicle market as an example. What's the problem? The problem is that slow charging batteries create charger congestion and range anxiety. It takes an hour to charge an electric vehicle. And the solutions today are only tackling the symptoms and not the problem. For example, making larger and larger batteries. If you buy an Audi e-tron, you're probably carrying like 1,200 kilos of batteries, not scalable. neither using many chargers or increasing the charging power. What you really need is a faster charging battery. And Dynami gives current and future battery chemistries faster charging by microstructuring the electrode. As an example, if you have a Tesla 3 and you want to make a 1,000-mile trip, it will take 94 minutes of charging to make that trip of 1,000 miles. That same Tesla.
Sorry,
Yes.
Sergio, we cannot see the slide actually.
What you're seeing?
I'm seeing your screen, but I'm not seeing the slides. Can you come back on where you were just before?
Okay, let's try without full screen. How about now?
Yes, that's perfect. Thank you.
Okay, it's I don't know. It's a problem with a Mac OS. Okay, so again, I'll restart. The problem is fast charging. Slow charging creates congestion. The solutions are not good. Making bigger batteries are not good. It's not good. You cannot make infinite faster charging stations. To give you an idea, a parking lot that holds 4,000 cars on a big supermarket, if every slot had a fast charger, you need a nuclear power plant to power that. It's not going to work. What you need is fast charging, because that makes smarter use of the grid. And our technology gives fast charging to current and future battery technologies. For example, if you want to make a 1,000-mile trip on a Tesla, you would need 94 minutes. And that same battery using our Honeycomb Electrode, it was contracted with that Honeycomb Electrode, it would take only 23 minutes. And how do we do that? Our solution is a physical solution inside the lithium battery. We make an electrode that is shaped like a honeycomb, but it's 1,000 times smaller. Our honeycombs are the size of a human hair, as you see on the center of this slide. Can you see that? Florian?
Yes, we can see that.
Okay. And that's the picture in the middle, and on the right you see the principle. This is based on a principle that is very well understood, which is secondary pore networks that allow the lithium ions to go faster into the depth of the electrode. So if you have faster lithium ions, you have faster electrons, hence faster charging and higher power. And this has been demonstrated in the science, but our technology is the first to create an industrial scalable version of this. And we make this by inkjet printing these electrodes using industrial inkjet printers. But the beauty that makes this fast is because the system self-assembles. We don't print the hexagons, but instead we just drop the drops on the surface, and they self-assemble into the honeycombs. And our solution is easily integrated into current manufacturing technologies of batteries, and it saves up to 80% of the energy used to make the electrodes. And the timing is perfect because the market is growing up to 20 times in the US, 16 times in Europe, and 4.5 times in Asia. This is up to the year 2030, and this is due to the introduction of EV technology everywhere. We have competition. We think we have the best manufacturability integration and the lower cost and the best flexibility due to our digital additive manufacturing technology compared to our competitors. And who are our clients? Are the manufacturers of current generation battery cells like CATL, Samsung, LG, Tesla, you name it, and also next gen batteries like QuantumScape or Solid Power, because our electrode fits into any battery architecture. We have a razor blade business model where we license our technology and we sell the inks to make the batteries, and we plan to hit the market in 2025. We have an international team, lean team. Dinami is a US Delaware corporation that owns a fully owned Argentine subsidiary and has laboratories in Buenos Aires, Argentina, and in College Park, Maryland. We are raising money, so all investors here are welcome to participate. This round is almost full, but we're going to be opening the next round mid next year, which is a scale-up round. So this is Dinami. We are bringing fast charging to most battery technologies today.
Great. Thank you so much, Sergio, and great, amazing technology. Great. So we're gonna move on, and we're going to have the presentation from Anderson Barkow from BoxPower. So Anderson, if you can join me on stage, perfect. Hi, how you doing?
Doing well, thank you. Pleasure to meet you all, and thanks for having me.
Perfect. Thank you so much. Everything is ready. The floor is yours.
Thank you. Well, I'm Anderson Barkow, co-founder and CFO at BoxPower. And living in California, I spend a lot of time worrying about wildfires. We're in the height of wildfire country up here in Grass Valley, and that has been a common problem that's been started by electric utilities from 2014 to 2017. They started over 2,000 fires, and they're presumed responsible for the Dixie Fire, which is the second largest in California's history this year. But what does this have to do with energy? Utilities are the cause, but they're continuing to not only in this application provide safe, reliable, and affordable energy, but in many applications throughout rural areas. And that's really why we're here. Our ecosystem of products and services accelerate the deployment and optimize the performance of rural microgrids, and we provide a clean, affordable, and reliable alternative to generators or the centralized grid infrastructure. One example of this is a project in the Tahoe region in California, where it would have cost about $3 million to upgrade a 4-mile distribution line to a single customer. Instead, they used a BoxPower system, which will save them over $2 million in the life of the system. This is one of our 3 main use cases, is this utility model. And these are 3 use cases where there's the highest avoided cost currently as costs continue to remain slightly higher. And so these are one, utilities where they see immediate savings, decreased wildfire risk, given the high avoided maintenance and capital expenditure of maintaining and upgrading lines. The second is critical facilities. COVID has only increased the importance of medical clinics, a key area we work in, where immunizations need to be refrigerated and operating tables need to stay open. The last is pure off-grid applications, where diesel generators are often running 24/7. And this is an application where we see 3 to 4 year ROIs with customers like telecom and remote agriculture projects. When we look at our process compared to how you currently make a microgrid, we're a turnkey end-to-end shop from design through operation. And what's enabled us to do that is a suite of hardware and software solutions that streamline this process and take out the many energy consultants, OEMs, developers, and electricians required in a normal project. These really enable us to get from these high first mover customers like utilities and telecoms to the mass market as costs continue to come down and we reach scale. The market as a whole is $87 billion for energy as a service and projected to be made up largely of microgrids, which are $47 billion by 2025. And just reiterating again, why customers like us to date is because we turn this complex process into a simple product. And the main 3 ways in the software and hardware we use to do this are 1, a software optimized design process. So this is a tool we built called the Energy Audit and System Integration, because we thought at first we could solve everything with hardware, but realized that one of our biggest challenges was that customers didn't know how much energy they used or which appliances were using it. And so this tool is a load disaggregation tool that helps customers understand their consumption and lets them set priorities on a size, reliability, resiliency versus cost and greenhouse gas emission reduction. And what this does is that the output of this is a selection of one of our turnkey hardware products that go anywhere from 5 kilowatts up to a megawatt. And this way, this catalog of products really reduces the engineering and logistic costs because they're already pre-designed and they install on site in a single day. And lastly, we're developing a control and monitoring platform through the California Energy Commission, which at scale will allow us to aggregate these assets and have megawatt hours of storage to balance grid operation, voltage, and frequency. We fit nicely in the market as a technology enabled developer, combining lots of existing technologies and partners to provide a turnkey integrated option. As I started with the fires, greenhouse gas emissions and fires continue to be one of the focuses of us, given where we're located. And like to end on the stat that the 2020 fire season in California had more greenhouse gas emissions than the state of California combined from an emissions perspective. So, not only is it wildfire risky to human life and damage, but also on a greenhouse gas emission side. And we're excited to be part of the solution solving that. Thank you.
Thank you so much, Anderson. That was really, really interesting. And thank you for being in the market. Actually, we need a lot of those companies. Thank you so much for being here. We're going to move on with Gordon, which is the president and CEO at UCAP Power. Thank you. Great. So I'm just going to wait for Gordon to be able to come. Or I'm going to move on with Pierre Gousseland in the meantime. If Gordon is not ready, just let me know, Pierre, if you can join us.
Hello,
Pierre.
Can you hear me?
Yes, I can hear you perfectly. Presentation is here, so the floor is yours.
Great, and sorry, for some reason the camera is not working. That's not the most important. So hi everyone, my name is Pierre Gousseland. I'm the co-founder of Terabase Energy. We are a startup based in Berkeley, California. We're about 70 people across 4 continents, and launched the company about 3 years ago. And since then did 2 rounds of funding, 1 seed round 2 years ago, and a Series A last summer. Do you have a control of the slide, or can I pass them to?
Yes, you have the control, Pierre.
Okay. So let me see how to control them. I don't see.
Okay, you can say next. I'm going to change.
Yeah, I say next because I don't see a control button.
No
Thank you.
worries.
So the management team of Terabase has been working in solar for the past 10, 15 years. And during that period of time, and as was mentioned during the panel, we witnessed very steep decrease of cost, 80 to 90% of cost reduction throughout a decade. Those cost reductions were mostly related to hardware cost reduction, mostly panels and then racking system and balance of system. We think at Terabase that the next untapped opportunity or pool of opportunities is related to soft costs. So the costs related to the development, construction, financing, and operations of a power plant. And that's what we are addressing at Terabase with an end-to-end platform consisting in IoT, software, and automation technologies. You also mentioned during the panel that the IEA is stating that the energy transition is not moving fast enough. We think that those technologies that we're developing can help accelerate the deployment of large-scale solar power plants. Today, I will focus mostly on construction technologies, although we are developing an end-to-end platform starting in the development phase and addressing construction and then O&M as well. So next slide, please. Before I dive into what our construction technologies are all about, let me give you a quick snapshot on the US market specifically. Wood Mackenzie and the SEIA have issued a forecast recently about large-scale solar power plant growth in the US. And they're predicting that about 240 gigawatts of large-scale solar will be built over the next decade. When you look at the interconnection queue, it might be much higher actually. The current interconnection queue across the US is about 460 gigawatts. So might be the number that we should be targeting instead. Could be even higher potentially. So the question is, next slide please, how do you build such a large amount of solar power plants? And by the way, that value is or that number is just for large-scale power plants. It doesn't include DG and so residential and commercial installations. What is the size of a 240 gigawatt worth of solar power plants? Well, it's about 48 the size of Paris. So imagine having to cover that surface area with 500 million PV panels over the next 10 years. Next slide, please. The way it is done today is fairly manual, utilizing some conventional means and methods, which present big challenges, right? You would have to have access to a massive labor pool. And we already see that this is a bottleneck in the US with the demand for this labor like booming over the past quarters and years now. It presents also safety risks. A lot of projects in the US see days where the temperature exceeds 45 degrees C. Once people are hired on those projects, we do see a large turnover. One of our customers recently mentioned that they had to hire 4 people to finally have one person who was willing to work throughout the project duration, which obviously causes cost and schedule impacts. So the solution we are developing, next slide please, is aimed at addressing those, both reducing costs, but also accelerating the deployment of solar power plants to really help reach, enable the energy transition and meet the carbon and climate change targets. Our approach consists in combining both automation innovations and software innovation. On the automation side of things, we are developing a temporary factory that is deployed on site for the duration of construction of the solar project. In that factory, we are pre-assembling the solar structure, so PV panel, trackers, cables, and so forth. And then the second component is a table moving equipment that will dispatch these pre-assembled units to their final installation location in the desert. The picture here is just indicative, that is not representative of a solution we have developed, by the way. And then the software side of things is here to help enable this automation. Up front, before construction, the software helps to plan the project and to find the best way to build a project, manage all the different type of panels and trackers, all the different SKUs. And then the software is there to help control and orchestrate the construction or the manufacturing, the fabrication of all the parts, and then the dispatch into the field. We have successfully performed some tests in our research center in California and are about to do our first real-life project. It's a 12 megawatt chunk of a 400 megawatt project in Texas. This will happen in Q1 next year, before we're able to scale in the US and then globally, internationally. So feel free to reach out if you have any questions about this automation technology and about any product that we have developed within Terabase and are now offering to the market, whether it's early stage software or late stage software for SCADA management and so forth. Thanks for your interest and your attention.
Thank you, Pierre. Really great presentation. Thank you so much for joining today. Great. So we're going to move on with our next presentation, and we're going to go with Vince Wong, which is the co-founder and CEO of Electric Fish. So Vince, if you can join me on stage.
Hi. Good afternoon.
Hey, how you doing? Perfect.
Great.
Great. So yes, you can share your screen, and
Okay.
the floor is yours.
Okay, perfect. I'm just pulling up the window. Let's see. Is full screen okay here?
This is perfect. Thank you so much.
Awesome, because I know there was some issues earlier. Great. So I'm Vince, co-founder, COO at Electric Fish, and our vision is to enable the energy we all deserve. We know that climate change has brought on a number of challenges, but also opportunities for how we rethink the energy infrastructure that exists. And there's a number of converging forces that are driving this sort of transformation. We know that we're trying to go all electric. Certainly here in the US, Europe has certainly been leading the way for a number of years, but this is really truly a global phenomenon. And we know that, for instance, in the US, some of the largest energy transformation will happen in transportation in terms of the energy loads that will grow. At the same time, we're trying to deploy intermittent renewables, which are extremely hard to capture, but extremely important for thinking about a renewable grid. And in terms of the impacts of outages and climate change, these are most disproportionately impacting disadvantaged communities. We know that climate change is certainly a universal problem, but the impacts are certainly felt most acutely with disadvantaged communities. And all of this is underpinned on one thing, which is the grid. We heard earlier from the panel before that the grid is extremely important in terms of how we think about this energy transformation, but it's extremely centralized and fragile. We're talking about architecture that's almost a century old at this point. And as we think about continued outages, peak charges, as well as some of the permitting challenges of getting this infrastructure installed, these will only serve to inhibit the clean energy transition. And we're hearing from some of the leading utilities that it's extremely expensive to future-proof and harden this infrastructure to support this transformation. And so at Electric Fish, we're trying to lead the way by building a distributed network of energy storage to power this clean, resilient, and equitable transition we know we need and want. And so in terms of how we think about building the utility of the future, it starts with location, location, location. We're building a patent-pending siting optimization tool that determines the best places to co-locate energy storage to support things like EV charging, taking in impacts such as where the grid might be underfunded, places where there might be more outages, and places where you have expected EV foot traffic. From there, we leverage off-the-shelf hardware, which we integrate in-house, and we pair that with patented software energy optimization to do a number of things. We can profitably load balance within a single 350 kilowatt hour system to provide rapid EV charging top-ups at 350 kilowatts. We can also provide energy backup as well as peak shaving entirely with renewables. And we can do all this without interrupting and disrupting the grid. What's unique about our solution is we can plug and play effectively with existing electrical infrastructure at sites in dense, hard to deploy areas like urban gas stations or car dealerships, convenience stores. And in doing so, we avoid trenching and grid upgrades, which can take up to a year and a half just to get approved. And as we think about our impact at scale, really our goal is to develop this distributed network to enable grid resilience equitably. As we think about the value streams, it's a very low friction revenue share model that we have. We earn revenue from EV rapid top-ups. That's 5 to 10 minutes, so extremely similar to the gasoline filling experience. No more, 30-minute fast charging, so to speak. We are also to earn revenue from utilities, as I mentioned, by providing them with local backup energy at the feeder level. And in markets like California and Oregon, we're able to tap into regulatory incentives, and this is taking steam with a number of other markets as well. From there, we aggregate these revenue sources and provide a simple rev share to our service station partners in exchange for 2 parking spots. We offer very flexible lease or buy models, which will adjust the rev share percentage appropriately. We see a tremendous impact in just California alone, where there's 10,000 service stations. Our goal is to be at 3,000 of these by 2025, equating to a $400 million revenue opportunity and 5 million tons of CO2 abated. Collectively, this is 1 gigawatt hour of capacity, which will be very meaningful in terms of adding resilience back to the grid. And as we look ahead to 2050, our impact grows to 2 gigatons of cumulative CO2 emissions reductions. Our moat is really around how we're able to seamlessly maximize a value generation in a single system. We have a patent around the system design that enables us to charge EVs extremely fast, but without disrupting the grid. And in fact, adding resilience back to the grid with bidirectional backflow. And so unlike traditional energy systems or even EV charging systems, the ROI is extremely hard for them because of utilization and peak charges. Effectively, with our unique battery storage buffer approach, we're able to bypass some of those demand charges and also maximize utilization. As we think about our trajectory, we closed our pre-seed round earlier this summer and amassed a significant amount of interest from both service stations as well as other types of sites like convenience stores and car dealerships. We have 3 pilot sites identified, and we're currently at TRL 5. As we look ahead to what's next, next month we'll be debuting our sort of demonstration scale products in the Bay Area. And then from there, we're going to be kicking off a number of pilots with our identified pilot partners over the next couple of months. And that'll also lead into our seed round, which is targeted for Q1. And upon raising the seed round, we'll be looking to gain UL certification for the system, as well as migrate to contract manufacturers. We're a diverse and skilled team of domain experts. And so I'm co-founder, COO, second-time founder, and prior experience in management consulting and AI. Our founder CEO, worked at places like BMW, Volvo, and Oak Ridge National Lab, where he really developed the knowledge base and research expertise that drives our product vision. Nelio, originally from Brazil, previously worked at NASA, where he built full stack hardware and software systems. And then Fola, originally from Nigeria, is our chief sustainability officer. Currently PhD candidate at Stanford, where she's focused on energy forecasting and optimization, and is really building out how we interface with the grid. As we look forward to the vision we're trying to achieve, it's really about enabling the energy we all deserve. And so we know that we need tremendously resilient power infrastructure that's decarbonized. But at the same time, we want to ensure that this energy infrastructure is also equitable, as disadvantaged communities are typically the ones to go out first and come back online last. The goal in deploying in dense urban locations where typically it's hard to deploy is that we can increase access to this very much needed infrastructure on a more equitable basis, while also doing good for the planet. Please get in touch if you're interested. Thanks.
Thank you so much, Vince. That was a great presentation. Thank you so much for joining us today. Great, thank you. We're going to move on with Gordon. I think Gordon is ready. So Gordon is the president and CEO of UCAP Power. So he's going to present here any second.
Can you guys hear me?
Yes, perfect. Thank you so much. The floor is yours for the presentation of UCAP Power.
Thank you so much. Had some technical challenges there with the Mac Safari, and my name is not Troy. My name is Gordon Schenk. I'm the president and CEO of UCAP Power, and also for some reason my camera's not working, but that's not important. Thanks again. Next slide, please. As our name implies, our company, our vision is really all about power. We focus on high power, short duration applications with a focus really on disrupting the lead acid battery industry and other batteries by retrofitting things like wind turbines, generators, microgrids, autos and transport with ultra capacitors. And we'll talk about what that is in a second. Our focus really is on making a lasting impact. one example alone, in many of the wind turbines, we've retrofitted and removed the batteries. The uptime associated with now not having to worry about batteries failing saves annually 363 K tons of CO2, which is fantastic. And then, of course, ultracapacitors are very, very reliable. They essentially give you the ability to have very predictable service times and service outages. And so, therefore, our goal is really to help people keep working longer and keeping their devices up and running. Next slide, please. A little bit of history. The entire ultracap industry started a long time ago. It wasn't invented by Maxwell Technologies, but really Maxwell was the first company, public company here in San Diego to introduce the first large cell ultracapacitor, the first design wins in rail and wind, and then eventually in companies like Peugeot in auto, and then GM and so forth. In 2017, when I joined the company, we bought a company called NESCAP, which was our largest competitor at the time. They joined with us and merged with us and gave us a full portfolio. In 2019, the company, through working behind the scenes with Tesla, Tesla decided to acquire the company. Next slide, please. So if you look at our history since 2019, in May of 2019, Tesla acquired the company, essentially let a lot of the product and executive team go. We decided to form UCAP Power predominantly because a lot of our customers on the wind side, wind energy side, on the reserve power side, really wanted our solutions. And so we decided to form UCAP Power for that reason. So from July of 2019, with some seed funding and a small Series A, through December of 2020, we wound up shipping our first product, which you see right there. It's called the Power Block. That is really a 12-volt battery replacement. Works great in wind turbines, where we do a lot of our business early on. Works great in generator applications as well. Again, to replace the biggest failing item, which is typically the battery in those systems. In May of this year, through some special purpose funding, through a convertible note round, we announced that we had actually effectively bought back certain assets from Tesla, from Tesla Motors. And then if you Google the press, you can see what exactly we did acquire. So now we actually are the owners again of Maxwell Technologies, including the full IP portfolio on the UCAP side, as well as the product lines. Next slide, please. That actually makes us the dominant market leader in the space of ultracaps, having shipped over 80 million ultracapacitors. We're operating now in over 90,000 wind turbines worldwide. That includes OEM direct and retrofitting in the US. We're in a number of light, medium, and heavy duty trucking for engine start and stop, and also in EV buses for that initial push. You need to get off the brakes, and also for regen braking. And then we've shipped to over 7 million different cars for a variety of applications: start, stop, power steering, power braking, emergency door locks. And then, of course, we have done quite a bit of work most recently in the side of reserve power and grid. One thing really unique about ultracapacitors is that they have a quick charge discharge cycle, and as a result, they can handle a lot of the renewable smoothing and frequency stabilization that are big challenges for the grid industry and the grid players. Next slide, please. There's just a view here of our complete product line. Our own UCAP Power design product you see there in the upper left-hand corner. Again, a 12-volt expandable, sort of stackable product. And then I've done stuff for engine start modules, for wind turbines, for bus modules, and of course you can see the full grid rack systems. And we do sell just standalone ultracapacitors, which you see there in the upper right-hand corner, in various sizes that go into a number of applications throughout the world. Next slide, please. As a result of the acquisition, we now have a global footprint. We have a contract manufacturer in Houston where we do quite a bit of our own product. Then we also have a large facility in Korea, along with a lot of employees. And then we manufacture in Korea, of course, and in China. and now in Texas as well as a number of global sales offices. Next slide, please. And just really quickly, we did of course raise a round of funding to acquire the assets from Tesla. However, we are doing a growth round at the moment. So if anybody on this call is interested, please feel free to reach out to me directly. You can see my my email there, as well as my mobile number. And I want to thank again Florian for having me today and being one of the startups picked, and apologize for the technical difficulties. So.
No worries, Gordon. We made it work. Thank you so much for your presentation. Amazing technology as well. So we were very lucky to have you today.
Appreciate it.
Thank you. So we're going to move on with our last presentation for today with BJ. If you can join me on stage. BJ is the CEO of Nivo Up. And so he's going to present any second. Great. Hi. How you doing?
Hi.
Perfect. So the floor is yours for your presentation.
So I'm watching your screen right now, right? So, okay.
Yeah.
My name is BJ. I'm the CEO of Nivo Up. First of all, let me describe what we at Nivo Up are making. We are the definite leader in developing extreme fast charging battery, or SFC battery in short. A desired extreme fast charging battery can be recharged 10 times faster, last 3 times longer, while keeping a balanced performance matrix. Next slide, please. While there are many battery startups in the race, Nivo Up is the only one that is commercially ready today, with a real-world customer taking our battery for their system launch in as early as 2023. Nivo Up's status may help us all to redefine a problem with the battery. There are no shortage of battery breakthroughs, but their commercialization, nevertheless. Next slide, please. If we follow what Mr. Mars once said, scaling our high-volume battery production is insanely hard, and Tesla's own 4680 delay to cause the delays of its Semi and Cybertruck, unfortunately, only confirmed again. Next slide, please. So Nivo Up team engineer, commercialize, expanded the principle of fast charging improves uniformity as a core to realize an underlying advanced process breakthrough, and then innovate a manufacturing platform around it. Here I am just opposing Tesla's 4680 process as a reference. And next slide. As it turned out in curing dendrite, the dominant failure mechanism in the battery reaction, we have outperformed what most people are waiting for QuantumScape to commercialize with their lithium metal process. On the path to a 1 million mile battery, our validated process can support extreme fast charging, while Tesla is still striving. Next slide, please. All led to a three-way solution around one advanced process breakthrough. Our technology will not only act as a physical battery, but as a manufacturing platform to ensure a successful commercial integration, plus a digital twin, given that fast charging is essentially an accelerating agent protocol to facilitate an effective AI machine learning implementation. Next slide, please. During the Airbus summit held in in the last months. Their executive share with the audience. Technopress and Nivea has been honored to collaborate with Airbus Defense and Space in providing and validating the battery technology to prove those claims, which led to Nivea's wins of helicopter hybridization, CITI Airbus Next Gen for 2023 launch, and all the way up to 0E scheduled for 2035. Next slide, please. So concurrently, this adjacent market application will be industrialized by our extreme fast charging battery before 2023. Then the EPRI platform sometime during the 2023. Next slide, please. Our team of 60+ years of experience in scaling up battery production has been the cornerstone to overcome the insanity, or if we can quote again what Mr. Elmer's statement. Plus Dr. Akasaka coming from GSU's European joint venture, and Dr. Wayne, who co-founded SATI3, the industry pioneer in solid-state battery, have joined our executive team. Next slide. So do reach out to us if you are interested to learn our technology and also to join our journey. Thanks.
Thank you, AJ. That was a great presentation. Thank you so much for joining us as well today. Great. So we are done for today. So thank you again. Thank you to all the presenters. I hope to see you soon. Before we end this presentation, I just wanted to show you the program for our next events. And so our next event will be on November 10th around the mobility revolution. So I hope to see you there. If you have any questions, you can reach out to me there on LinkedIn or email. And so thank you again, everyone, for coming by, and have a great rest of your day. Thank you.